So first, we take the 0 of the factor. And the 0 of that factor is 3. And we divide it into the polynomial. So we have 1x to the 4th, 7x cubed, negative 19x squared, negative 103x, and 210. See if you can divide and see if x subtract 3 is a factor. What we got here? 11. What do you know, huh? Did you get what I got? So what can we determine? X subtract 3 is a... And why is it a factor? Because the 0 gives you a remainder of 0. Yes? That's the factor theorem. All right, on to 33. 33 says solve the equation. Remember to check for extra solutions. This is called a rational equation. To solve a rational equation, we want to make the denominators the same, and then we solve the numerators. And we want to make sure we write down the restrictions for x from the denominator. So to make the denominators the same, it'd be easy to factor. So x squared subtract 4 is called the difference of squares. So I'm going to do that. And by factoring, it becomes easier to recognize the last fraction. How can I make all the denominators the same? What does the last fraction need that it doesn't have? X subtract 2. Now, if I asked you, what can x not equal before you start solving? Would you look at the numerator or the denominator? And what are the zeros of the denominator? What can x not be? And it's positive and negative. So if that ends up being a solution, we have to cross it out, right? And that can't be a solution. That's a restriction. So now you only write down the numerators. Now, for this last numerator, I'm going to distribute. So when I distribute, that's negative 4 times x, and negative times the negative, which is plus 8. And that's what I'm going to solve. When the denominators are the same, solve just the numerators. And now you can recognize it's linear. Just combine like terms and solve it. So I'm going to add 4x. I'm going to go 3 plus 8, which is 11. And then the last step is to divide. Is that a good solution? Yes, it's not one of the restrictions, and it's done. All right, look at number 35. If I asked you, what are the restrictions? What can x not be if you looked at the denominator? This is a good skill to practice. Look at the first denominator. What can it not be? Can you do the inverse of what you see, right? So it would be adding 3 and then dividing by 2. How about the second denominator? Subtract 5 and divide by 2. Those would be the two restrictions. Why are they restricted? Because it makes a 0 in the denominator. Did you see how I got 3 over 2 and negative 5 over 2? Now, are the denominators the same? So what does the first denominator need that it doesn't have? 2x plus 5. This is also a proportion where you could cross multiply, but we're just using the same technique if it wasn't a proportion. The second fraction needs a 2x subtract 3. Now the denominators are the same. Just write down the numerators and solve it. We call it a proportion when we have one fraction equaling another fraction. That's it. Just one fraction equals another fraction. And then there are different techniques people use, like cross multiply to solve it. But we're sticking with the technique of making the denominators the same. Can you combine like terms? how would you get the x's together? So 12 subtract 8 is 4. How would the constants be together? That's subtract 30, so that would make negative 42. And then divide. Does 4 go into there evenly? No, right? So it is going to be a fraction. So you can reduce it down to negative 21 over 2 or negative 10 and a half. All of those are good answers. Notice it does not match the restriction, so we're good. Turn the page when you're ready. Number 37. Can you find the vertical asymptotes of that rational function? To find the vertical asymptotes, step 1 is, I'm going to factor the denominator. Can you easily factor that denominator? What two numbers multiply to negative 28? And the same two numbers combine to positive 3. And be careful of the signs. One would be positive 7 and the other would be negative 4. Do you know what I need to be careful about here? Is to make sure that there's nothing that divides out. Is there anything that crosses out here? Because why? What would happen if something crossed out? Would that be a vertical asymptote? No. Instead, that would be a whole, right? So it's not just looking at the denominator. It's making sure that nothing simplifies. So nothing simplifies. How do I write vertical asymptotes properly? Is I write x equals the denominator, negative 7. What's the other one? X equals positive 4. And those are your vertical asymptotes. And that shows where the graph is undefined. X cannot be negative 7. X cannot be positive 4. How do I show that on the graph when it can't be that? We draw asymptotes, right? That's what it is. And it comes from the denominator. Number 39. What are you asked to find? The horizontal or oblique asymptote. Now, to find the horizontal or oblique asymptote for a rational, it has to do with the power terms at the top and bottom. What is the power term of the numerator? 7x. What's the power term of the denominator? Are they equally powerful with exponents? Yes, right? If they're equally powerful, it's going to be horizontal. And all you do is divide. So that means the horizontal asymptote, power term over power term, when you simplify it, is just y equals 7. That's it. Look at number 41. What's the power term on top? 41. The power term is just x. What's the power term on the bottom? Are they equally powerful? No. Which one's more powerful? And when the denominator is more powerful, the horizontal asymptote is y equals 0. Look at number 43. These aren't long questions, so I'm going through them quickly. Number 43, what do I look for horizontal or oblique? Power term over power term. Are they equally powerful, top and bottom? Is the top more powerful by 1? That's the indicator there's an oblique. How do I find the oblique? Is by dividing. Look at the denominator. Is that a simple linear? That means I can take the 0 of the simple linear and divide it into the numerator. I don't need to do long division. But to find the oblique, you do have to divide. So if the top is more powerful by 1, it's oblique, and you have to divide to find it. And because the denominator is simple linear, I can use synthetic division. So drop the 1 down, 7 times 1, and add 7 times 9. This actually doesn't matter, the remainder. What does matter is the part that's not the remainder. That's the oblique. And so what would you say the oblique is? How many x's? 1x plus, that is the oblique. So, recap. If the numerator and denominator are equally powerful, you're going to divide the power terms, whatever number it is, it won't be 0, whatever the number is, that's the horizontal. If the top is weak or the bottom is more powerful, it's always y equals 0. And if the top is more powerful by 1, you divide, and that oblique, which is a slanted asymptote, is found by dividing. Those are your 3 situations. All right, number 45. Number 44 and 45, we are going to start graphing rationals again. And these are what are called reciprocals. So I'm going to remind you what a reciprocal is, because it's been a while. The reciprocal function is y equals 1 over x. That's the parent reciprocal. There are 2 points and an asymptote on that, 1 over x. 1 point on 1 over x is 1, 1. And another point on 1 over x is -1 and -1. All the other points are fractions. There are also 2 asymptotes. And the 2 asymptotes are x equals 0 and y equals 0. We are going to transform these. To change the x, you look at the denominator. How did x change in the denominator? What was it before? X. What did it become? X subtract 1. So what does that tell me I need to do to each x coordinate? And for the x's, you do the inverse of what you see. So it's not going to the left, it's going to the right. We're not subtracting 1, we're going to add 1. So 1 plus 1 is 2. -1 plus 1 is 0. 0 plus 1 is 1. All the x's, you add 1. How about the y's? Where do you look to see how that has changed? And to see how the y has changed, you look at the numerator and what follows. The numerator tells you to multiply. What follows is either adding or subtracting. So what am I going to do the y coordinates? Times what number? -2. And then what do I do? Subtract 3. So let's follow it. 1 times -2. Subtract 3. So what's a point on my graph? And -1 times -2 is +2 plus subtract 3. So negative times the negative is +2, subtract 3. So we have 0 and -1. And then lastly, the asymptote is always the k, or 0 times -2 is 0, and subtract 3. That is what we're going to graph. So the asymptotes are at x equals 1. So here's a good reminder. Let's say there's one question for you to practice, right? But you need another question to practice. Where would you go to get more practice or look over the video or notes or whatever, right? So you need to put a star or something, right, that recognizes, hey, I might forget this. This is going to be one question on this, at least on the final exam. All right. The other is y equals -3. And then there are 2 points. One point is at 2 and -5. And the other is at 0 and -1. Now, what does the curve of a rational look like? So, as it goes to the right and left, the end behavior is going to be the horizontal asymptote. So, what's the right end behavior? -3. What's the left end behavior? Also what? -3. But what happens at the vertical? What direction does it go? It's either going to go to infinity or -infinity. So the one above is going to go to infinity, and the one below is going to go to -infinity. If you are asked to find the end behavior, what would you say the end behavior is here? As x approaches infinity, what does f at x approach? -3. As x approaches -infinity, what does the function approach? -3. So the left side and the right side both approach the horizontal, that number, -3. So if you're looking at it and you recognize, I don't remember this, I don't know if I got it the first time, or I kind of got it the first time, then you have to make sure that you go back and study it. All right, 47. These questions now are not reciprocals. These are rationals. We are not going to make butterflies out of 47. Instead, we're going to find intercepts, asymptotes, table of values. We're going to put it all together. So step number 1 for 47 is to factor. Can you factor 47? Factor the top, factor the bottom. And one step at a time, we're going to analyze it and put it on our graph. So what are the two numbers that factored the numerator? Positive 7 and negative 6. How about the denominator? Negative 8 and positive 7. Right now, we're going to write down the domain restriction. Can you tell me what x cannot equal before I do anything else? Where do I look? The denominator or the numerator? Okay, what can x not be? Positive 8 and negative 7. Now, we do what you want to do. Is there any factor that's common that matches here? So what factor eliminates? Now, what does that tell you? That tells you there's a whole. What's the zero of what you eliminated? Not the factor, but the zero. Negative 7. How do I then find the y coordinate that goes with this whole? Is I take that negative 7, I can do that on the side, and I plug it in to find, hey, what's the y coordinate that goes with negative 7? So that's negative 13 and negative 15. So the answer is pretty close to positive 1, but not quite. It's just underneath positive 1. But it's important to recognize a negative divided by a negative is going to be a positive answer. So the whole is at negative 7 and 13 over 15. What are some other things I want us to be able to find? What are the zeros of this function? Do I look at the numerator or denominator to find the x-intercept? And the answer is I look at the numerator. And I look at the numerator of the simplified form, not the one that I crossed out here. So the only numerator here, what's the x-coordinate there? Or what's the 0? Positive 6. You don't see it, but what exponent is on there? And because the multiplicity is odd, what's going to happen at positive 6? It's going to cross over. What else would be helpful? What's the y-intercept and how do I find it? To find the y-intercept, I plug in 0 for x. And when I do that, I get negative 6 over negative 8 or positive 3/4. What's the last thing I need to focus on? Is the asymptotes. We have a vertical asymptote. Where's the vertical asymptote and where do I look? The numerator or denominator? What's the 0 of the denominator? So it's x equals positive 8. Does this rational function have a horizontal or an oblique asymptote? Because the powers are even, right? And what is x divided by x? X divided by x is what an answer? Now we're ready to graph this. So the vertical asymptote is at 8. The horizontal asymptote is at 1. I have some points to put down. Oh, I also have a whole. The whole is at negative 7 and 13 over 15, which means it's just what? Just below, right? The asymptote. It's not quite 1. We have a point 0 at 6. And we have a y-intercept at positive 3/4. Now, I want you to notice that we have 2 points in a whole, but they're all to the left, right? We need one to the right. What's an x value that I could plug in to give me a point on the right of the vertical asymptote so I have another point to curve through? So if I go 10 subtract 6 or 10 subtract 8, what answer do I get? 4 divided by 2. So we have a point at 10 and 2. So we have another point that we can curve through on the right side. Can you complete the curve of this rational? So I know the right end and the left end behavior is the horizontal asymptote. So the right end and the left end go to the horizontal. What happens in the middle at the vertical? What direction is it going to go? Either infinity or negative infinity. So the one above is going to infinity and the one below is going to negative infinity. For the end behavior, as x approaches infinity, f at x approaches 1. As x approaches negative infinity, f at x also approaches 1. Now, what you might need to do, because it's on video, is that you might want to take a blank piece of graph paper out and then slowly go through each step again, right? If you got too fast, too confused. You can also go back into our website and the notes and the videos to go back over each one of those steps. All right, turn the page, 49. So, in question number 49, can you look at a graph and eliminate bad answers to be left with the right answer that matches it? So look at the graph and see if you can eliminate ones it cannot be and be left with the one it must be. I'll give you a moment to look at it. And on the video, you can obviously fast forward so we get to the answer. So a good place to start is where the asymptotes are. Where is the vertical asymptote? So what number? -2 and what? Now, if I work backwards, what must the factor be? So if the 0 is -2, right? If you work backwards, what must be in the denominator? X plus 2. Yes or no? Cross it out. Yes or no? Good. Yes and yes, right? So when I look at the denominators now, do they match? Another place to look. Where's the x-intercept? The 0. At positive 2. So when I plug in positive 2, does it give me the answer 0 on top? Now we got to look at some other things. Next, look at D. What do you notice about the exponents on the vertical asymptotes? So the multiplicity is even or odd? Now, when the vertical asymptote has an even multiplicity, that means on both sides would go down or on both sides would go up. They wouldn't split what direction they go. So on these, do you notice one goes down and one goes up on both sides of the asymptote? D is wrong because it is an odd multiplicity here, where one goes up and one goes down. Now we're left with B or C. What's the only difference between B or C? One says x subtract 2, and the other says 2 subtract x. Do you see the graph on the right side? Is it above or below the x-axis on the right? Above. which means that as you put in large numbers for x, the answer is positive. So in other words, if I plugged in positive 4, would the answer be positive or negative? Positive 4. Negative, right? Or positive? Here, positive 4 gives you what answer? A positive answer or a negative answer? So if I plug in positive 4 here, does it give me a positive answer? If I plug in positive 4 here, what answer does it give me? Negative. So which one's wrong? So the only one that's left, right, as we thought through it is C. Just working backwards and thinking and eliminating, right? All right, turn the page. Next, how much pure acid should be mixed with 5 gallons of 50% acid in order to get 80% acid solution? What type of story is this? What happened? Yes, tell me. Probably. You've been going this long without a packet?
No. I didn't grab the entire thing. This master got like 6 half.
Oh, no.
Yeah.
All right. So the answer is yes. I'd have to print it out. I don't have one printed out. But from this page on, you have to have it printed out. From this page on. All right. So let me set it up, and then I'll print it out for you. So, do you remember how to solve a mixture problem? Step 1 is, what are you mixing? Well, first I'm mixing pure acid, correct? Then what am I mixing with pure acid? A 50% acid solution. And then what's our end is our end mix, yes? After mixing those together. There are 2 things I care about. One is the quantity, and the other is the percent of acid. And you don't need to change the percent to a decimal. So, how much pure acid do we have? I don't know, so it's just X. How much do we have of the 50% acid solution? 5 gallons. How much will the end mix be? Well, we'll add them together. It's X plus 5, whatever that is, right? That will be the end quantity. What percent of pure acid is acid? If it's pure acid, then the whole thing is acid, correct? What percent is the 50%? And then what's the end mix? Now we have an equation. So we multiply these together. So we have 100x plus 250 is equal to 80x plus 400. Solve it, and you have your answer. All right. All right, Eduardo, I'm printing it out for you right now. Oops. Okay, so to solve this, combine like terms. Subtract 80 and you have 20x. Subtract 250 and you have 150. Can you divide it and tell me what the answer is? 150 divided by 20 or 15 divided by 2? So, how much pure acid should be mixed? And the answer is you should mix All right, number 53. In number 53, a train leaves a station traveling at 32 kilometers an hour. 2 hours later, a passenger train leaves the same station traveling in the same direction at 52 kilometers an hour. How long does it take the passenger train to catch up to the freight train? Do you know what type of question this is? This is a rate question, right? There's a formula we use for rate. Do you remember that formula? There's a word we use to help remember it, right? Did you say pert? Oh, close. It rhymes. Dirt and pert rhymes. So, dirt. Now, do you recognize that we have two trains here? One's called a freight train. Know what that is? Yeah, it sounds scary. And then the second one's a passenger train. Now, what do we know about the freight train and the passenger train? We know the freight train is traveling at 32 kilometers an hour. How fast is the passenger one traveling at? Now, which one has a head start? Which one has more hours of traveling, the freight train or the passenger train? So, if the passenger train is X for time, then whatever X is, you have to add how many hours to the freight train? Because the freight train has 2 more hours, right, that it's traveling? And what do we know about the distance for both of them? All we know is that when they meet, the distance is exactly the same. So what you do is make them equal to each other. And now solve it. Good morning. So I got all kinds of good stuff there? Can you put that on the back table back there for me? And then I'll organize it later. Thank you, Jesus. I'm not even going to mention it. There's no need to mention it. Aw. There's all kinds of good stuff here, right? Did we have a good practice yesterday?
I didn't go.
Oh, man. All right, that's on video. So, hey, can we solve this? 32x plus 64 is equal to 52x. Thank you, guys. And then combine like terms. So we're going to subtract 32. I'm pretty sure that's 20. And then divide by 20. And if I reduce it down, I think 4 goes into both evenly, don't they? So it's like 8 over 5. Something like that, right? So how long will it take the one train to catch the other train? And it would take 1.6 hours. All right, number 55. And part of me doing this is recognizing that we need to have something to go back to, right? So when we do a video and it's maybe going too fast for you because you totally forgot this from like a month or two ago, you have to focus and have a good attitude to it, but recognize you now have a resource to go back to slower if you need it. 55. I have a good feeling about 55. Maybe I shouldn't. Can you tell me what type of question number 55 is? Do you recognize it? I like the idea. It's a work problem, right? And when we talk about a work, it is going to be the reciprocal, isn't it? So Brandon can paint a fence in how many hours? 12. Elaine can do it in how many hours? So how long if they work together, right? So, do you remember to set this up? So, if it takes 12 hours to do the job, every hour, what fraction is being done per hour? So, Brandon's finishing 1/12 of the job. Elaine is finishing 1/11 of the job every hour. So how many hours, if they work together, would it take? So I need to get common denominators here, correct? So I'm going to multiply the top one times 11. I'm going to multiply the next one times 12. And then the last one needs both, and it also needs x. So the denominators can be the same. And the last one needs an 11 and 12. So recognize the denominators are the same. So we have 11x plus 12x. Do you know your 12 times tables? 11 times 12. Is it 121? It's not 121. It's 132. 11 times 11 is 121. 132. So 23x equals 132. Then you divide. So what's the approximate answer to that? I think it's 5 something. So how long would it take if they work together? All right, turn the page, 57. Remember, I'm going to scan this and put it on our website. So if it's going too fast, you'll have the opportunity to even print it out or write it out from the website. Let's do another one like that. But I'm going to let you read it and see if you can set it up. And then you can see all kinds of old favorites that are following the stories, right? I know, exactly, right? Doesn't get sound. Number 57. So when you read 57, is it also a work problem? So can you set up the equation for the work? So first, what's doing the work? How many pumps are there? Now, 2 pumps can fill a water tank in 45 minutes. That's not individual, is it? That's together, is it not? So we actually know if they work together, how long will it take them? So every minute, how much of the job is getting done together? So every minute, how much of the job is getting done? So the rate is 1/45 per minute of the job getting done. What else do we know? Well, we know alone the second pump takes 3 times as long. So if pump 1 takes that long, then the second pump takes that long in terms of a rate. And 3x is the slower pump, right? Takes longer. X is the faster pump. Now, how would you solve that? Common denominators. What will the common denominator be? And the answer is that it's going to be 45x. So I'm going to multiply by 45. I'm going to multiply by 15. And then the last one, I just need to multiply times x. Are now the denominators the same? So we have 45, we have 15, and then 1 times x is x. Done. Add them up. And how long does it take the faster pump? Now, which one is faster, the first one or the second one? The first one, right? The second one takes 3 times longer. So how long does the second one take? 180. But I'm asked for the first pump alone. So the first pump alone takes how long to fill the tank? All right, the next group of questions have to do with radicals. And then I'm going to give you time to work on what you need to work on. So, look at 59. Do you know how to simplify a radical? So what's root 7 times root 3? Root 21. What's root 7 times root 5? Is there a perfect square that simplify these? No. That's the answer. Done. Isn't that crazy? There's no way to combine them together because they're not like radicals and they are prime. There is no perfect square that can simplify them. Look at number 61. What does it mean to rationalize a denominator? It means to make the denominator a rational number. How can I make that a rational number? Multiply top and bottom by root 5. So I have 9 root 5 over 5, and it's over. Number 63. How do I make this a rational number when it's a binomial? Say it. The what? The conjugate. Now, what's the conjugate? I know. What's the conjugate of 5 take away root 10? It's 5 plus root 10. And then multiply it out. So 4 times 5 is 20. 4 times root 10 is 4 root 10. And then the denominator. 5 times 5 is 25. Now I don't need to FOIL it because it's a difference of squares. Just first times first and last times last. So negative root 10 times positive root 10 is just negative root 10, negative 10. 25 take away 10 is 15. And this is done. There is no number that goes into all 3 numbers evenly. You have to look at 24 and 15. So it's prime. Hey, 65. Do you know what a fractional exponent means? Are we getting closer to where your memory is or no?
Yes.
Hey, the denominator. What does the denominator mean in the exponent? Root. So what number 4 times itself is 81? What number 4 times itself is 81?
3.
3. And then what do I do with 3? 3, we apply the power of 5. What's 3 times 3 times 3 times 3 times 3? Turn the page. All right, 67. What kind of equation is 67? It's called a square root equation. How do I solve it? So how do I undo a square root?
You square.
So we're going to square both sides. What type of equation do we have now? It's a quadratic. How do I solve a quadratic? As I make it equal to 0. So I subtract 10x. I subtract 24. I hopefully factor this easily. What 2 numbers fit here? Perfect. 6 and 4 do not work. So negative 12 and positive 2, which means my 2 answers are positive 12 and negative 2. Do I need to double check to make sure there's no extra solutions for this? Yes. Can a square root equal a negative number? No. So which answer is extra? So the only correct answer is 12. Number 69. What does that little donut mean?
Oh, that's composition.
No.
Do we say fog? F composed by G, right? Now, a composition is just a substitution. G is going to be plugged into F. So F is 6x plus 13, but you take out the x, what goes in its place? What gets plugged in? The G, and then you just simplify it. 18x So what is the composite function there? And it's 18x plus 7. Look at 71. Is this also a composite? But what's different is we're not evaluating at a variable, but at an actual number, a constant. So how do I do f composed by g at 2? What do I do? First, I plug 2 into what? So if I plug 2 into g, what answer do I get? 2 squared times 2, and then add it up. What answer do you get when you plug 2 in? 11, and then what do you do with that answer? Is you take that answer and plug it into F. And it's 22 plus 6, which is 28. 73. What are you asked to find in 73? Do you remember how to find the inverse? So what's step 1 to find the inverse? The x and y are switched. Now, how do I solve for y? What would be a good first step? And a good first step would actually do the reciprocal to both sides. That way y is not in the denominator. What would you do next to get y by itself? What's the inverse of dividing by 2? And when you multiply times 2, what would be the next step to get y by itself? Nope, the other one. Subtract 5. And then what would the last step be? Divide by 3. Now, when you divide by 3, it means the same as times the reciprocal, right? You could actually leave the answer like that if you want. You could also write the answer as 2 over 3x minus 5/3. All of that is good. And what's the symbol for inverse? That little negative 1. All right, turn the page. This is the last one we're doing. And then I'll continue on when I see you next. So, 75. Can you find the inverse of that function and then state the domain and range? So, if I want to state the domain, I know that x cannot equal 5. If I want to find the inverse, I switch x and y. Now, in this situation, the reciprocal is not going to help us. So instead, I'm going to multiply both sides by y plus 5. I'm then going to distribute.
Is there staple? Isn't staple so the percent?
Oh.
Oh, I didn't see.
So I distribute. Any term with a y in it needs to be together. So I'm going to subtract 3y, and I'm going to subtract 5x. So any term that has a y in it is going to be together, and if it doesn't have a y in it, it's going to be on the other side. Then I'm going to factor out a y. And by factoring out a y, y now will be by itself. So the last step is to divide. So it's negative 5x subtract 2, and then x subtract 3 in the denominator when you divide. And again, the symbol for inverse is that little negative 1. What's the domain restriction of the inverse? And x cannot equal 3. The question says, what's the range? Well, then the range, what can x not equal in the inverse is what the range is for the function. The range of one is the domain of the other. All right, so that's the odd questions up to 75. That takes us well over half the semester right there. Mr. GMAP, over.